So hi you guys. Hope you guys doing well. We just gonna give maybe 3 minutes more until 6:05 to see if someone else joins and then we can start. My plan will be to go again to the review we saw in the lecture on Sunday, the Python review. And then after that, I suggest you guys ask questions about the previous homeworks we we saw. We had three or four homeworks previously that involved Qiskit, and I'm sure there's lots of doubts. So I suggest to this basic review first, and then we go through the homeworks. Okay. So yeah, I'm very excited about the COVID shots. Here in New Hampshire is gonna be open next Friday for everyone 16 plus. Did you guys got your shots already? I'm still waiting. Because here everyone's very excited. I cannot see the chat, but do you get yours, Heath?
Not yet. I think I'm going to be in the last group to get mine, but patiently waiting, hoping here in the next month.
Oh, which state are you in?
I'm in Virginia.
Oh, yeah, I think in April, second week in April, Virginia gonna open it. Yeah, it's very exciting. I got an overflow shot 2 weeks ago. No, 1 week ago. I stayed there and begged. Like I went there a week and I was like, hey, please, you guys have an overflow. Then one day there was one left. I said, yeah, come in. So I got mine, waiting for my second shot now in April. So yeah, 6:05 now, gonna start. Even in this during this basic review, if you guys have any doubt because we're so few here, you guys can ask. It's fine to ask questions, okay? With few people it gets much easier to ask questions. So on Sunday we saw forgot how to pronounce his name, Aksha, I think. He showed us some basic functions, actually some basic functions on Python, and I'm just going to review them here. Okay, so in the notebook he shared with us, he explains about variables. The first thing he says about variables and data types, and by definition, variables are containers for storing data values. Python has no command for declaring a variable. Variable is created the moment you first assign the value to it. The equal sign is used to assign values to variables. The operand to the left of the equal operator is the name of the variable, and the operand to the right of the equal sign operator is the value stored in the variable. Variables do not need to be declared with any particular type and can even change type after they have been set. I'm gonna try to zoom it a bit more so you guys can see it. Okay. So we're gonna create two variables here, and they're gonna be called name and page. Okay, and then we're gonna print this statement. So now I'm creating the variable name. I'm gonna put my name, and gonna create bit. And in Python, to assign a value, a number, you don't need the symbols here, the quote symbols here. You can just write a number because it already understands as a number. And having that, I can print it. I'm gonna try to use what is already here. So the name of, sorry, the value. I'm trying just to do what he did. The value of name. And here it's important to put a space here in this command to print, because if you don't add any space here, I'm gonna do it wrongly, so I can show you guys what happened. I'm not gonna put the space intentionally. And the correct way to add a number here is say string here, to put a command string here. And let's see what happens. See that when I print like that, if I don't add any spaces here, it doesn't add any spaces here too. So the area we're gonna add spacing is right after the statement. So see the value of Giselle Beach 1. Okay. So yeah, it's a very simple thing. It's how you add variables. Now, if I change and I say, I don't know, I'm gonna write name in Portuguese, nome. And I'm gonna write here, I'm gonna misspell. I'm gonna put byte, whatever. And then it's okay since I change it here again. It's gonna work the same, okay? So the important thing here is to be consistent. How you define your variables here is how you should write them here. Because if I say name here, you should bug and it's working. I'm gonna write anything else here. It's now bugged. If you are not concise when you write in the code, it's gonna bug. All right, B here. It's not gonna work. But now if I put M and I write B here, then it works again, okay? So yeah, printing the statements, what I did there, I was just playing around with printing thing. Now next topic. Lists. Lists are used to store multiple items in a single variable. Lists are created using square brackets. List items are indexed, and you can access them by referring to the index number. The indices start at 0. Okay, in any list you write in Python, the index of the first element is 0. Okay, and then it's 0, 1, 2, 3, and so on. It doesn't start by 1, so it's something to pay attention to. What we're gonna do here, we're gonna create a list named MyList to store names of all the quantum gates we know, and print the whole list, the length of the list, and the 5th element of the list. So yeah, let's see how we do it. As the first thing we do, we assign a variable and a name, and we put the brackets. So we type brackets to prepare to print the list. It's basic thing. Now I'm not gonna retype everything again because I have the text here. Again, I'm just gonna copy it and put it here. So that's how I created my 0th index here is X gauge, okay? So it doesn't matter how and what I type here. It's just because like I know the name of the gauge, but inside here I could put fruit, I could put fish, I could put anything. it would still create a list. I'm just following what the exercise suggested. That's putting the names of the gates we know, but it could be oranges, peaches, whatever you like can be inside here. And again, it needs to be concise. Whatever you write here, you need to write here. If you want to print this list, you need to write the same thing here. So when you command to print, you need to write exactly the same thing. Now, if I put print list here, it's probably gonna bug. See, it bugs because it says my lit is not defined. Of course, it's a list. So it's a very common mistake. Sometimes an entire cell of code bugs because you forget, you mistype something. It's annoying like that, but that's the only way you have it to work precisely. You need to type it the very thing. So it's even better if you copy and paste the name of stuff to make sure. It happens to me all the time. I mistype things all the time, and my program bugs. Lots of times I also, instead of printing length to typing length for the length of my thing, I do this or this, and I forgot to spell it correctly, or I add a dot here and it doesn't work. You need to be precise in your commands. So the length is gonna give the length of my list. And if I try to print the fifth element of my list, do you guys remember I said it starts with a 0? So the fifth element, you count 1, 2, 3, 4, 5. It's gonna be here, the fifth element, but it's indexed by 4 because it starts with a 0. So 0, 1, 2, 3, 4. Okay, so that's how it works. Now, a hint, if you want to, let me just let you guys see the rest of the list here. It goes until RX gauge. It's because it's so zoomed we can't see. Now a hint, if you want to, the length of the list in C naught is in the 4th position. Now, if you want to use all the numbers in the list, you can count from right to left, and if you add -1, it's RX gate, that's our last, I'm gonna do here because I'm pointing to my screen that's shared. It's gonna be in the end of this list. It's the RX gauge. If I do -6, it shows the X gauge because the index starts on 0 for this side, but it's negatively from right to left. It doesn't start with 0, it starts with -1. So it helps sometimes when you're trying to find things on Python when you're programming. Sometimes it makes more sense. Yeah, I can't from top of my head tell any example when this happened, but it happened when I was programming that I needed to find more logic in what I was doing. So I had to start from the back. So just remember that in this case, the element is gonna be the highest value, the lowest in negative. It's gonna be the first one, okay? And here, it bugs if I try to print the 6th element because we have indexes until 5, not until 6. So for the last element here, it's gonna be 5 or -1 also works, okay? Control flow and loops. Python supports the usual logical conditions from mathematics: equals, not equal, less than or equal to, greater than, and greater than or equal to. And now we're gonna see it in an example for if statements. It's going to be clear in the next cell when we run, we're going to use these commands. If statements. If statements are used to perform actions if a certain condition is true. An if statement is written by using the if keyword. If you want to test for multiple conditions sequentially, use if followed by elif and or else. Elif is just the short for else if. Like if this doesn't happen, then if this happens, that's why it's elif. Elif is else if. Python relies on indentation, white space at the beginning of a line to define scope in the code. Other programming languages often use curly brackets for this purpose. If I'm not mistaken, Java uses curly brackets. Question 3. Create two variables A and B and store a bit, either 0 or 1 in each of these variables. These bits might have been result of a classical measurement on a 2-qubit quantum circuit, for example. Print A is greater than B if A is greater than B. Print A is equal to B if A is equal to B, and print A is less than B if A is less than B. So yeah, here it's already written, but I will explain line by line. So we assigned to the variables 1 and 0 values because we pretend we're playing with qubits and the Z bases 0 and 1. And if A is greater than B, and then we use 2 dots here, and then you see the indentation here, and Jupyter Notebook is really good at like adding the this tab after things. But if not, if you're doing something wrong, you know that sometimes when you write lots of lines of code and you delete all, you can bug this tabbing, this spacing thing. Sometimes it happens. So it might be that it doesn't add the spacing for you. You just need to go and press tab and make it work. But usually Jupyter Notebook is already very good on it. After you put 2 dots, it already indents it for you. So, and if you don't indent, it can bug, or it can perform a different action. So it's important to put indentations where they belong. So yeah, if A is bigger than B, greater than B, we're gonna print A is greater than B. We can print anything here, anything that's in between these quote signs will be printed. If I want to print my name, if I want to print anything here, if I want to print oranges, it's gonna work. It doesn't matter what you print here, but be sure that in the end your program is gonna be very messed up if you don't print something that makes sense here. And believe me, it happened to me before. If you print something that's very nonsense, you get all confused, you can't do it anymore. So just be careful with the messages you're printing to print things that make sense, and yeah, to help you to understand what you were doing all along. Also, whenever you, I forgot to mention, whenever you want to mute a statement in Python, you can just add the hash symbol here. This mutes the command line here. So if I want to mute A, I just do this. If I want to unmute it, I do that. Okay, the hash, like I say mute the variables or mute the line of command. So if you just like showing things or like testing things, you don't need to delete everything you did. Let's say you want to add another condition, you don't want this condition. You want to add if A is smaller than B here, you can just mute this and write it again. And then it's a great way of testing without taking too much time. Okay. So I do this all the time when I'm testing my commands. I mute them and I run the program, and then I test again, and I keep muting the commands and unmuting them to test possibilities. It's a very useful thing to have, not and also to have a clean program and a very ordered program, because let's say you wrote this code and then you don't touch it for 2 months. Then when you come back to it, you have no idea what it does. But if you put some notes here, it helps you to keep track of your good work. So it's a good practice to always it's some little note about what you're doing. So you don't get lost. Here it's a very simple thing. We know what's going on, but it can be that you have a huge program that you have no idea, and then it's good to have some notes for what you're doing. It's good practice. So following here, else if or elif, A equals B. And see here we're using double equal signs to compare. We're not assigning a value, different from here up here when I am assigning values. I'm comparing values. When I'm comparing the values, I use two equal symbols. And then A is equal to B. Else, of course, it's if the opposite happens, if A is smaller than B, you can print A is less than B. You can put else if again, it should work, okay? But because it's the last condition we have, you don't need to put another else if, you can just put else. And it's a very important thing because sometimes we just concerned like what is going to count for our program is just like two conditions will interest to us, and if something happens not going to be interesting to us, and then it can be that you forget to put the else condition. What if nothing of this happens? And then it's important to use an else thing. If nothing of this happens, I need to have an alternative what the program is going to do, otherwise it's going to bug. I can try to mute it here to see if it bugs. Let's put, gonna mess up with the variables here too. Gonna here and one here. And then the program doesn't know what to do because there's no like the condition when A is less than B because it's muted here. But if I unmute here, and I hope now it works, it should work. As A is less than B. So if I don't put this else condition here for when everything else happens, it's not gonna work. Now let's have a look in for statements. A for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. And all these things you can find a definition elsewhere. What's a list, a tuple, a dictionary, a set, or a string? There are different types of sequences we have, the possibilities we have in Python. In Qiskit, we're using most of the time, we're using strings. Sometimes we're using lists, and very few times we're using dictionaries. I'm not saying we're never gonna use a tuple or any other form, but I'm just mentioning what we use. Okay, the range function returns a sequence of numbers starting from 0 by default and increments by 1 by default and ends at a specified number. So let's keep this in mind and see question 4. So it's little bit of the problem of QKG we had. And it's as if we comparing the very last part of the program, seeing if they get the same values. So it's gonna run a comparison, okay? So Alice and Bob have been using QKD to build their keys. The length of their keys is Alice's key, of their keys is Alice's key is 8 bits. Alice's key is 00110001. Bob's key is 0010004001. Store their keys as strings in two variables named Alice key and Bob key. Next, compare their keys one bit at a time and print whether each of their keys match or not. So now, the way we are assigning our strings here, is important to put code because it's a string, it's not a number anymore. If I don't put the code here, Python is going to understand this as a number and it's going to be wrong. To assign string, it's important to put the code here. Okay, the marks here. The same with Bob key. And now we're going to run a loop comparing for every element in this string, comparing item by item if they're the same. So we know that the for loop works writing the word for. So for I in range age, and I could use any other letter here, but by default for Python, we use I for index. I could use any other letter here, but by default, we use I because it's a very easy way to understand it's an index. But if I decide to change this letter here, I should change everywhere where I have I. If I decide to change it by E, F, wherever, I need to be to respect this and change everywhere. But by default, I is what we use to index things. And just out of curiosity in Python, when we have to write the square root of -1, instead of writing I, we use J, because by default, the Python uses I for indexing. So whenever you want to write a complex number, we use J, okay? That's a curiosity. They had to change it. Yeah, so for I in range 8, and 8 is the length of this string, starting from 0 until 7, okay, because the range is 8, so 8 elements. If Alice key I is equals Bob key I, this means I'm comparing the same index for each string here. I'm comparing 0 to 0, 0 to 0, 1 to 1, 1 to 1, 0 to 0. That's what it means because I'm not comparing Alice key I to Bob key I plus 1, for example. I'm comparing to Bob key I. I'm not comparing to a specific item. I'm just saying that they both vary at the same time, okay? So if this happens, the bits at index match and this position of the string match. Else, because we only have the condition when they are equal or they are different. So I don't need an else here, I just need an else. So else, for anything else, that's the second condition in this case, the bits at index do not match. So yeah, so it's gonna keep printing because I didn't tell the program to stop at any point. I just said to keep comparing because for each I in this range, that's what it means. It's not gonna stop. If I said in a smaller range, it wouldn't. We can test it now. Let me see if I'm saying it wrong. If I say the range 7, it's gonna compare to the 7th element, to the 6 index, the 7th element. I can say until when I want to compare. Okay, if I say in the range 8, it means I'm going to compare all the indexes here, okay? So functions, I hope this is clear. You guys can stop me and ask questions at any moment. Functions, function is a block of code reference which only runs when it's called. The idea is to put some commonly or repeatedly done tests together and make a function so that instead of writing the same sentence again and again for different inputs, we can call the function to reuse the code contained in it over and over. Functions can be both built in like print, input, compile, exec, etc. And user defined because also gives freedom to create your own functions. So let's see it better. Defining and calling a function. So this is a super simple function that has no parameters, no arguments, it just says my function. And what it does, it prints hello from qubit by qubit. So to call this function, I just need to type my function and then hello from qubit by qubit, because that's what the function does. So it's a very dumb function that does pretty much nothing here, but we can complicate it, putting arguments. It means that inside here, we can add things to make this function works, doing fun stuff. So arguments are information that can be passed into functions. Okay, information can be passed to a function as argument. So arguments this information. In the argument, we're going to include the information we want to give. And arguments are specified after the function name inside the parentheses. You can add as many arguments as you want, just separate them with a comma. Yes, you can add as many arguments you want, but also if you want to use them all, because like if you don't need more than 2 arguments, you shouldn't add any more. You're gonna add arguments, as many arguments as you need to run the function. So we're gonna create a function to compare Alice and Bob keys from question 4 and call this function. Call this function, okay. The function is gonna be called compare. And inside this function, I'm gonna have 2 parameters or arguments, A and B. And in principle, I don't know what's the length of A, and I don't need to know what's the length of B. I just know that they should be the same length, okay, to this function to work. So I'm gonna use I to index because it's the default indexing thing for Python. For I, and look at the indentation here, okay, after the def for definition, defining a function, I have an indent here to apply my for. For I in range, and then the range is gonna be given by the length of A, because I want a function to be the most general as possible. So the length of A, and I'm gonna compare index by index A to B, and then I'm gonna print if they match or if they don't match. It's a simple function, and we're gonna see in action. So here we just no, we're not repeating, we're having a different, we have different strings here. So I'm just defining Alice key and Bob key. And then A and B, now I'm gonna call Alice key is gonna be my parameter A, and Bob key is gonna be my parameter B, okay? And then I'm gonna just run the function. And I forgot to call the function here too. That's why it's not working. Now I can call the function again. So yeah, one of the things that happens too is just sometimes we forget to run the cell above, and then it seems it's bugging, but it's not. It's just a matter of like running things. If I don't run this function, if I don't tell it's working, it's not gonna work. And then for this range here, these are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The range is the length of A, it's 10, and B, we wrote like the same size of string. That's how this function is gonna work. And it's comparing item by item. Now, if I want to change, I can just say to compare for I don't know, for 7 things. And then I need to run it again. And just gonna to compare to this index 6 here. So I can mess up with the function, but if I want to make it general function, oops, a general function, I need to be less specific. So whenever you want to build a function, you want it to be less specific as possible so you can use it. So it's not that when you create a function, Python is going to memorize it forever. It's going to be valid for this piece of code, for this notebook. Let's say you remember at some point you built that function, you want to use it again. So you need to go to that code you used before and then find the function. And then you can control and paste the function again and make it adjust it according to your new code. It's not that like at this point Python is going to put in the library. It's not. It's just going to memorize for this notebook you're using. So if at some point you need to use this function again, you need to copy it and to put into a new code. Okay. So this ends the review on the basics of Python. And I think this is information enough to start understanding better what Qiskit is doing. It's now the best moment to ask questions about any of the homework questions you guys want. Feel free to ask. No question is dumb. If it's not from the homework, you can ask about Python in general. I can try to answer. But now it's the moment to ask. So you guys should ask now. Feel free. Either via chat or talking or muting the microphone. I don't have access to the chat, so I will rely on Heath to tell me if there is any question in the chat.
I think we should be able to see it. Chat set up for anyone to share something publicly. So
let me see if I'm doing something wrong here.
I haven't seen any messages.
Okay. Yeah, I can see the chat, but maybe it's because there's no messages. So guys, either it was super bad or super good because I don't see any questions. Okay. Yeah, I saw many questions on Piazza, and I thought you guys would be in doubt today. So, okay, I will ask questions then and see if you guys want to do something. Let me open. I have a very tricky question. Let me find it. Aha. Does anyone know why B is reaching this funny way here? So if I want to see your guesses. Because before this call I was talking to the person who wrote the code to try to understand. And it was a question on Piazza. Someone answered it well there. So yeah, it was a question during homework 18. I remember when I was holding that section, someone asked me, and at the time I didn't know how to answer it very well. I'm not sure if I can still answer it 100%, but I can give you guys a hint. Just let me do something here first. Gonna find an alternate way to write this. Just find it. I have it written here. Yeah. So what this means is that in a short, just gonna mute it here so you guys can see. In a nutshell, this line of command here means that for each term in this Bob string, whenever the element inside Bob string is different from 0, I'm gonna append this to the list B. A means that I'm ignoring the terms that are 0. And why this happens? It happens because when we're doing the snapshots in the circuit, I need to run this again. I'm gonna go to the updated version. You can see it better in the updated version. So whenever I'm doing these screenshots in the circuit here, whenever I'm doing screenshots and the screenshots taken as barriers here, but there's a screenshot and there's another screenshot here in the end. I'm collapsing states because screenshots are not supposed to happen in real circuits. So it's somehow messing up with the order of these strings. It messes up the index of B. It doesn't mess up with the order of A because I didn't do anything. I started with the Alice state here. And like the index are not messed up, but whenever I take a screenshot, I'm collapsing states, so I can be messing up the states and changing the orders of the variables for B. So the only way to make sure I'm not calling it in the wrong order is writing in this way. So it's not still 100% clear explanation, but it's a good way to say that if I do the same for A, instead of starting as 0, if I start doing the same for A, it makes more sense. So whenever I find an element on Alice string that's different from 0, I'm gonna compare and sum. And that's what's doing here. Okay, so it's something to keep thinking. It's a good thing to read about list comprehension in Python and see that doing these screenshots is not a natural thing to do. We do this here in this exercise just as a smart way to compare, but snapshots cannot happen in real life. If you guys remember this homework, snapshots are not supposed to happen in real life. So we did this as a trick. And as a trick, we need to contour to go around the problem and re-index B. It was a smart way that Phil, the person who wrote the code, found. And I found it very, very, very clever. Maybe if we could write these snapshots in another way, just taking qubit 2, we could do that. But so far, snapshots don't work like that. We cannot just take Q2. So whenever we're taking here, because we have these Hadamard gates, we're collapsing in 1 or 2 in the snapshot. So we need to make sure it's not 0, it's always 1. And that's why. So yeah, you guys are very silent. And yeah, I think I'm gonna let you guys go because there are not too many questions. Either it's completely nebulous and foggy, or you guys are awesome. So I will imagine you guys are awesome. And yeah. Okay. So I think we can wrap up